Okay, we're going to talk about what is called confidence intervals. Confidence intervals. We just went through a political election for the governor of Virginia. It was highly publicized governor of Virginia election, also the New Jersey election, the governor of New Jersey. But when we deal with all these elections, you have people, entities, corporations, universities that do polling. They survey people. Who you're going to vote for. And they break down all the statistics so they can sit there and make as many predictions as possible in regards to what's going to happen in a political race. It will start up a huge entity, or the Senate has midterm elections coming up next November. So there's going to be so many polls that are going to be shoved down our throats in regards to, if you watch news, any type of newscast, it's going to be a lot of political polls of who's going to win this Senate race, who's going to win this Senate race, so on and so forth. Okay, and then when it comes to a presidential election again, it's going to hype up and amp up again 2 years after that. I mean, or it won't even be 2 years after that. It will start right after the 2 year the elections next year. It will start up again. But when we talk about confidence intervals, people want to be able to make predictions on who's going to win elections, or who's going to, elections is a huge entity that we deal with respect to this. Okay, this is a poll that was done on, let's see, October 20th to 26th. It had this guy 1% behind this guy. Okay, Youngkin and what's this guy's? McAuliffe and Youngkin. But over here, this is what they're predicting at this point. They did a poll of 1,000 people, or they did a poll of 500 people. And this is what they came up with respect to their poll. But if you read the small print here, okay, and this is what is going to be in every poll. They have little small print that's there, and you can barely even read it. Okay, I would have to try to find somebody's glasses to be able to read the small print. Okay, this is plus or minus 4 percentage points, which means if I would take a look at the first guy here, this is 49%. This is plus or minus 4%. So the first guy here could be anywhere from 45% to 53% of the votes. Youngkin over here is 48% plus or minus 4%. So he could go from anywhere 44% all the way up to 52%. There's so much emphasis put on these polls. The news people will shove these polls down everybody's throat. Just shove them down everybody's throat. But if we take a look, this guy could be anywhere from 45 to 53% of the vote. This guy could be 44 to 52% of the vote. So this guy could sort of blow him out. I mean, if this guy's at 45% and this guy's at 52%, and he wins by 7%, that's a pretty high margin. That is a pretty high margin. So when you look at these polls, you take a look at, well, what's our possibility of an error? When there's room for, let's see, overlap at any point, and there's a huge room for overlap here, it's anybody's race. And they can sit there and tout these numbers. Oh, 49% for this guy, 48% for this guy. But it really means not much because of this right here. But political people, the news class, the CNNs of the world, the Foxes of the world, the Fox Nations of the world, all those newscasts, they make money off of this. The people that do these polls make money off of these things. If there's money to be made, they're going to do it. This was a week before the election. This was a week before the election. If we take a look what happened in the election, he got 50.6%. He got 48.6%. This was the actual election results at that point. So he was within that range, and this 48% was within that range. And that's what they're trying to predict out. They're trying to predict a range of values here. But unfortunately, so much emphasis gets thrown on these two values right here, which misleads the public. It misleads people and tries to steer them in one direction or another. Because ultimately, people want to vote. People want to be on the winning side. We got the Bengals and the Browns playing this weekend, last weekend. We want to be on the winning side of that. We want to be on the winning team. We don't want those Bengals to win. Maybe some of you did. Sorry. But you want to be on the winning team. You want to feel good about it. You have two teams that you really don't care about, but you're watching a football game. One team starts winning the other. Okay, I'm going to start cheering for that team a little bit more. This right here, he gets 40. He's 49% of the people want him. Only 48% of people want him. You know what? I might start going towards this guy a little bit more. Why? Because 49% of people want him. I know nothing about either of these two people. But 49% of people want this person. I'm going to maybe vote for that person. So they can steer votes. How they can steer votes with that. Once again, knowledge of what is being provided for you is very important in the political arena and these polls that are being done. You must be very knowledgeable of what's going on. Don't go by just the headline. Read the additional things, because 49% could go 44 to 53%. This 48 could go from, or 45, 44 to 52%. Okay? So there is a wide range of values. Okay? Them saying it's a dead heat, yeah. They had no idea what they can predict, or they had no idea what to predict. So when looking at the political venue and looking at polls, okay, as you get older and older, you get a little bit more interest. Who becomes senators for you, or who becomes presidents? Okay, when you start looking at that, take a look at the fine print and the small print, because that's where the story is being told. They never, ever sit there and talk about this plus minus. And when you look at polls, when you look at polling, when they see there's an overlap, here's an overlap, there's an overlap in these values, there's a chance, there's a good chance. Okay, if we had 50% plus or minus 4% and 44% plus or minus 4%, okay, 50 to 44, somebody says, oh man, this person's going to win. They got 50%. Half the people want that person. but that's plus or minus 4%. So this could stretch all the way down to 46%. This one can stretch all the way up to 48%. All of a sudden, the person that's getting beat by 6% is now up by 2%. If we go to the extremes of my plus minus margin. So once again, just don't look at this number. The New Jersey one, I couldn't find the poll numbers, and I was looking for the poll numbers this morning. The New Jersey one was even further spread out. But it was a dead heat. It ended up being very close at the very end. So if these polling numbers, this plus minus, takes us to a range where we're going to have a chance to win, okay, it's not a guarantee that this 50% person is going to win. Because ultimately, they are only surveying maybe 500 people or 1,000 people. That's a small sample compared to an entire state that's going to be voting. Where, in this case, it was 1.6 million. People voted for one, 1.6 million voted for it. So you had 3.2 million people voted. And I'm only taking 1,000 people out of that 3.2 million people that voted. Okay, that's tough. That's a tough call to be able to do that. This is called a confidence interval. Here's some strange stats of the day. Average life expectancy of an enemy soldier in a Chuck Norris film is 4 seconds. Cost of raising a medium-sized dog to age 11, $6,400. Medium-sized dog. Age 11, $6,000. Probably even more expensive now, because all their dog food's sitting out there in the ship somewhere in Los Angeles. It costs more money to be able to ship it in there. These are estimates of the population. These are estimates of the population. Once again, as we talked about, when we talk about a parameter, we talk about a population. Okay, a survey could be going out there to Dr. Gerber's Country Corner Vet. You know, somebody may go in there and do a survey about dogs. Hey, do you mind if I ask somebody, have them fill out a little survey real quick? And it could be very easily, how much food do you buy for this dog every month or every week? Okay, how much food does this dog go through? Okay? If you have a big dog, you have those big old 50-pound bags of dog food that you have to put over your shoulder to be able to take it home. Little dog, man, you can usually pick it up with one hand. You take a look at the vet bills that you have to pay every year. Have to take to the vet. The grooming bills. Okay, if you live out in Los Angeles, you got the spa fee for the dogs. You go to the spa, they have a spa day, get your nails clipped. This was from years ago, so $6,400 probably is about $10,000 now. When we talk about a point estimate is a specific numerical estimate of a parameter. A specific numerical estimate of a parameter. That is a point estimate. On the back of there you go. The point estimate is a specific numerical estimate about a parameter. And most of the time we deal with the standard deviation or the mean. The best point estimate of a population mean is just the sample mean. That's your best point estimate. You just take your sample mean. Whatever your sample mean is, use it. It may not be exact, but It's a ballpark number. That's close enough. You know what you could do for that point estimate? Go to a vet office, attract a medium-sized dog, age 11, find the cost per 1 year. And once again, how you can find the cost per 1 year? You take their vet bills that they have for a year. You know, how much food do they take eat a month? How many bags dog food do you have to buy every month? You got the Fifi, you have the treat, the bacon treats, bacon treats that you have to give them. Okay, all the treats, all the toys that you buy your dogs because we like them. So much for the old school. You just tied up a sock and you threw the sock at them and let them run after it. A sample mean is a better estimator than the sample median or mode. The sample mean is a better estimator than the sample median and mode. Okay, and this will be another test question that you'll need to know for the test. You got to give me a property or two of a good estimator. The estimator should be unbiased. Properties of a good estimator. Estimator should be unbiased. PetSmart should not be doing the survey on how much it costs for a medium-sized dog to age 11. Because if you tell somebody that it's going to cost you $11,000 to raise this dog to age 11, they may get a little sticker shy. So they're going to taint the numbers a little bit so it doesn't look like it's going to cost as much because they're in the job of selling dogs. PetSmart wants to sell dogs, so they don't want to scare people away. The estimator should be consistent. As sample size increases, the value of the estimator approaches the value of the parameter estimated. Once again, law of large numbers. The law of large numbers. You want to have a sample size increase. You just don't want to track one dog. How much does that one dog cost? And say that's going to be every dog. You want to increase your sample size and calculate a mean of the sample size. They say if you have a jar of pennies, a mason jar full of pennies, and you want to estimate how many pennies are in there, the best thing to do would be to ask everybody in this class, give me your number. How many pennies do you think are in there? And take the average of those people, and you'll be close to the value of the number of pennies in there. An estimator should be relatively efficient. Best estimator with a small variance. So you want to have a smaller variance, which is going to give you a smaller standard deviation. Okay, we're going to take a look at a problem that type of problem that we just did. Average vehicle registered in the United States is 8 years old or 96 months. Assume a standard deviation of 16 months. If a random sample of 36 vehicles is selected, find the probability that their mean age is between 90 and 100 months. So we are given mu is 96 months, which is 8 years. We're given a standard deviation of 16. We have a sample of 36 vehicles. And we want to find the probability the mean average age of these 36 vehicles is between 90 and 100. Well, this is a problem, that type of problem we just did. You had to calculate a z for 90 and a z for 100. So we have value minus mean divided by standard deviation divided by square root of n. Okay, it's the exact same thing we just did. Value minus, or your mean minus your population mean, your sample mean minus your population mean, divided by the standard deviation divided by the square root of n. So find your two z values. Then you're going to have to go to your z table. Determine your two areas from your z table. Once again, this is nothing different than we just did. Then what do we have to do with our two table values then? Grace, what's your two z values?
1.5.
Okay, so those should be your Z values. Table values, Jack, what do you get for our table values?
First one is 0.4878 and 0.4382.
And what do we have to do with those? And what do you come down to?
0.9210.
Yeah, you get 0.9210. So if I take these 36 cars, there's a 92% chance, that my average age is going to be between 90 and 100 months. 90 and 100 months. This is the percent probability the mean sample is between 90 and 100 months. Once again, this is a percent probability. But what this also, how else this could be stated, is that 92.1% of the cars are between those two ages. 92.1% of those cars are between 90 and 100 months. %92 of the cars are between 90 and 100 months. It goes back to the day we did the Arctic squirrels in here. We did the survey of Arctic squirrels. And there was a percent chance of getting a certain person or picking a certain person. Why? Because that percent of people in this class enjoyed that number, or that type of Arctic squirrel, or that number of people enjoyed that type of flavor of Arctic squirrel. So it can also be stated as a percent confidence that the mean lies between 90 and 100%. We are 92% confident, 92% confident that the mean's going to be, if I take 36 cars, the mean's going to be between 90 and 100%, 100 months. If you're 92% confident something's going to occur, if you're a betting person, would you put $100 of your own money down if you're 92% confident it's going to occur? If you're 92% confident something's going to happen, would you put $100 of your own money down to win another $100? If you're 92% confident. You have a chance to win $100 here. You're 92% chance, 92% confidence it's going to occur. So you have 92% chance it's going to occur. You put $100 down to win another $100. Interval estimate. Is an interval or range of values used to estimate the parameter. This may or may not contain the parameter being measured. The interval estimate is an interval or range of values used to estimate a parameter. This may or may not contain the value of the parameter being estimated. For what we just did up there, the interval estimate would be 90 to 100. I'm 92% confident I'm going to be in between these two values here. So that's your interval estimate. The confidence level is the probability the interval estimate will contain the parameter. Assuming a large number of samples are selected, and the estimation process is the same, is repeatable. Our confidence level was 92%. We are 92% confident that my range for the mean is between 90 and 100. And once again, all good experiments are repeatable. We will stop there. No homework for tonight. We'll finish our notes tomorrow. Over confidence interval. They have nothing tonight. Got a night off. Enjoy. Have a good day.